In today's lesson, we'll be working on 4-4, expand expressions, and we're going to do it in the form of Cornell notes. This, in your book, you will see on pages 207 through 212. Okay, but we're going to do them in the form of Cornell notes today instead of using the book pages. So we can go back to the book pages with additional problems or examples if you need to, but make sure you have a sheet of Cornell notes, that you give it the title with today's topic or objective, just like I've done here. Also make sure that your name and class period are on your paper, as well as today's date. The essential question for today is, how does the value of an expression change when it is expanded? So we're going to be looking at this lesson from the viewpoint of another property that we use in algebra called the distributive property. So we will first start with the question, what does it mean to expand an expression? In order to answer that question, we need to know about a property in mathematics called the distributive property. In the distributive property, you have a number or a value outside a set of parentheses, and then you have an expression inside those same parentheses. And what it tells us to do is to multiply the value outside times each piece inside. So let's take a look at an example. In this example, we have 3 6/10 as the term outside the parentheses, and we're going to be multiplying that times each term inside the parentheses. Inside the parentheses, you have the expression t plus 5. So we're going to take the value 3 6/10, and we're going to multiply it times t, and then we're also going to multiply it times 5. So as we do that, we are going to expand the expression. Here's what it looks like. So notice that the term 3 6/10, again that's the number outside those parentheses, has been multiplied times each piece inside, the t and the 5. So now we're going to work to simplify this. In other words, let's get rid of any unnecessary symbols and combine any like terms that we have remaining in the expression. Well, the first part of this we cannot multiply, but we can shorten it up. So instead of 3 6/10 times t, we write 3 6/10 t. So we're just going to get rid of that multiplication sign. In the next part, though, we can do the multiplication. So we can actually multiply the 3 6/10 times 5 to get the product 18. So now our simplified expression, after we have expanded, is 3 6/10 t plus 18. That means the same thing as 3 6/10 times the quantity t plus 5. That's how you expand an expression using the distributive property. Question 2. How can I expand an expression by distributing a variable? Well, the distributive property works to multiply any value outside parentheses to each term on the inside of parentheses. So let's take a look at an example to see how that works. You'll notice in this expression you see two different variables. X is on the outside of the parentheses, while inside the parentheses I see one term that has the variable y. We're still going to do the distributive property here, but this time what gets distributed is the y, and it will be multiplied times each piece on the inside. So as we multiply, you'll notice that the x gets multiplied by a -2 first. There is subtraction between the terms, so we leave the subtraction sign. And then we have x being multiplied times 5/10 y. Now we're going to take these two expressions and simplify them. So I'm going to put red parentheses around those so you can see how that multiplication gets grouped together. For the first group, x times -2 makes a -2x. So we always put the number in front of the letter. We still have subtraction between the two expressions. So then we're going to leave that subtraction, and now we're going to multiply x times the 5/10 y. Well, remember 5/10 y is the same as 5/10 times y. So here we have three pieces being multiplied together. The number doesn't have anything to go with it. But then we see two variables, an x and a y, and we typically place those directly after the number, and they go in alphabetical order. So we're going to put the x in front of the y. It's not wrong if you have the variables in a different order, as long as you have them attached to the number by multiplication. So remember that number in front of the variable is going to be the value that tells us how many times to multiply. So our simplified expression here is -2x minus 5/10 xy. Now go ahead and flip your paper over. Let's try one more example before we go on and do some additional work with more complex expressions. In the next example, you see a t variable on the outside of the parentheses, and inside the parentheses you have the expression -1 2/10 w plus 3. So in this expression, we're going to distribute the t and multiply it times each of those pieces inside parentheses. So our expression looks something like this. Now that we have our t distributed to each of the pieces inside those parentheses, we're going to simplify. So in the first expression, t times -1 2/10 w means that there is only a number value, -1 2/10, and then the other two pieces are variables, a t and a w. And we're going to put those in alphabetical order. T comes before w. So we write the t first. Plus, we're going to multiply the t times 3, and we can't really do that, but we can reorganize that term so that the 3 comes in front of the t. And that's all there is to it. So when we distribute or expand an expression, we are taking away the grouping symbols, those parentheses, and taking the number outside and distributing it to each piece on the inside through multiplication. Question number 3. How does the distributive property work with more complex numbers? First, see if you can simplify the expression. Then you're going to use the distributive property. So let's take a look at an example that shows this same process. Look at this expression, -1/3 times the quantity 2 minus 3x plus 3. When I see that expression, the first thing that I notice is that there is some simplifying that I can do inside the parentheses. I have a couple of terms here that I can combine. In this case, 2 plus 3 makes 5. So my expression can be simplified first to say 5 minus 3x. I combined my two like terms, which are both constant terms, so those can go together. Now I can use my distributive property. I'm going to take my -1/3 and I'm going to multiply times 5. And then I'm going to take my -1/3 and I'm going to multiply by x. So -1/3 times 5, remember that means to multiply your numerators and denominator. And when I see -1/3 times x, I can't actually do any multiplying there, but what I can do is simply take out the dot. Now, when you take a look at this expression, do you notice that you have subtraction and you have a negative term that follows it? So remember that that means that we can simplify by adding the opposite. So my expression is -5/3 plus the opposite of -1/3 is a positive 1/3 x. So there's my simplified expression for that example. Here's one more example. -2/5 times the quantity 10 plus 15m minus 20n. When I look inside those parentheses, I don't see any like terms, so I cannot simplify first. This time, I have no choice other than to just go ahead with my distributive property. So I'm going to take my -2/5 and I'm going to multiply times 10 plus, oops, let's make that black. There we go. I'm going to take my -2/5 and multiply times 15m. Oops, that's supposed to be in red. Let me change that. Minus, I'm going to take my -2/5 and I'm going to multiply by 20n. So you'll notice here that my -2/5 has been distributed to each piece inside those parentheses. So I had to distribute it this time 3 places instead of 2. Now I'm going to simplify by multiplying that fraction times each of those terms and then simplifying where needed. So let's take a look at what we get. Remember that each of those whole numbers is having a denominator of 1. And when I multiply fractions, I multiply straight across the top. So I get -20 and straight across the bottom times 5. Plus -2/5 times 15m is like -2 times 15, which is -30 divided by 5 times m, minus -2/5 times 20n is -2 times 20, which is -40, and 5 times 1, which is 5, and that term has an n attached to it. So to finish this one, we're going to simplify by looking at the division to see if we can actually divide or simplify those fractions. In each case, The numerator and denominator will divide to get a whole number answer. So negative 20 divided by 5 gives me negative 4, plus negative 30 divided by 5 is a negative 6 times m, minus a negative 40 divided by 5 is a negative 8n. Now there's one more step that I have to do here, and that is to shorten up those subtractions and the opposites, and let's rewrite that and make it look a little bit cleaner. So negative 4 plus, oops, let's change that. Because adding a negative is the same as subtracting 6m, and then subtracting a negative 8m is the same as adding 8n. So there's my final cleaned up expression. And that expression means the same thing as the expression that we started with back up here. So this will conclude your Cornell Notes paper. This page should now go inside your binder, or you may tuck it inside the pages for lesson 4-4. I would put it between pages 208 and 209. And let me write that down here for you. Page 208, 209. That's where this paper can reside inside your book. Now I'd like for you to go into your book on pages 210, 211, and 212.